Hello students, this is part 2 of my lecture on chapter 2, labor supply. So in this part we're going to focus on certain policy applications, welfare programs and work incentives. In other words, what is the effect of US welfare programs on the work incentives of its recipients, of the program's recipients. And so the main points here are that cash grants create work disincentives, welfare programs create work disincentives, and welfare reduces the supply of labor by increasing non-labor income, which raises the reservation wage. We learnt in part 1 that the higher the non-labor income, the higher the worker's reservation wage, right? And welfare programs essentially deliver to workers a non-labor income, right? So let's look at the microeconomic theory of this in more detail. So let's first work with a cash grant, right? So the story is as follows. In the beginning, the worker has no non-labor income. So his point of no work is in fact point E, right? So he has zero non-labor income. V, capital V is equal to 0. And so this is his budget line. As you can see here, his wage is that slope. W, that's his hourly wage, right? And his best point, the point that the combination of leisure and consumption that maximizes his utility is point P, right? Where the indifference curve labeled U0 is tangent to the budget line. So this is the consumer's optimal point to begin with, right? And now the government comes along and gives this individual a very high cash grant, just a lump sum payment with no strings attached, right? So this is a $1,000 cash grant, $1,000 per week, which is of course a very, very substantial sum. And what this does is, pardon me there, what this does is it causes the point of no work to now be G, right? And we know that the reservation wage at point G is higher than at point E, correct? So what may happen now is that the worker may, as you can see in this diagram, the worker may simply choose point G itself. So you see this indifference curve here labeled U1, right? That seems to be the highest level of utility that this person can get now with the cash grant, right? And so the worker may choose not to work, right? And in fact, if I were to draw in this diagram itself the budget line outward like this, right? That of course would be parallel to the blue line that you see here. And you can see quite clearly that the reservation wage, which is the slope of the tangent to the indifference curve at point G, the slope of that tangent, very poorly drawn, but you can see that that slope is less than the slope of this blue line, which I'm trying to replicate here with a dotted line like that. Right? So essentially what you have at point G, is that the wage is less than the reservation wage. So the worker will choose, in fact, not to work, right? So essentially what this diagram is saying is that before the cash grant was disbursed, the worker used to work 40 hours a week, which is the difference between capital T, 110, and 70 hours of leisure, right? So this is 40 hours of work, but after the cash grant was disbursed, the worker decides not to work at all. So the individual essentially stops working, perhaps leaves the labor force, right? Here I've made a little note here. It's a note that Republicans were concerned that generous unemployment benefits during the coronavirus pandemic acted as such a disincentive. Follow me? So while the Democrats were trying to disperse cash grants to people and more generous unemployment benefits, the Republicans were always concerned that if unemployment benefits were too generous, people might just stop working, might lose the incentive to in fact, enter the labor force, right? All right. All right, now let's look at the effect of a welfare program on hours of work. So we're not looking at the, the binary decision of whether to work or not. Let's look at the actual hours of work, okay? So what may happen here, so this program is not a cash grant, by the way. So here you have a certain lump sum that is given, let's say $1,000 a month. It says your monthly grant of $1,000. But this sum is reduced by 50 cents for every dollar earned by the welfare recipient, a kind of phasing out of the grant. So you're given $1,000, but for every dollar you then earn by working, the government reduces the $1,000 tax grant by 50 cents. So in effect, what this does is this is taxing the earnings. So if you're earning, let's say the wage rate is $10 an hour, right? And you receive this $1,000 grant, and you decide to work 1 hour. When you work that 1 hour, what the government does is it reduces that $1,000 grant by $5, which is half of this 10. So you now get $995 of a cash grant, right? You get to keep this entire $10, but in effect what has happened was this is equivalent to your wage becoming $5 an hour, because that's what you've really taken home in net, correct? So that is why if this slope here were the original wage, if the original wage were $10, then if you decide to partake in this program, your wage is going to be this slope, which is $5. So the new budget line is this one here, right? Let me switch my pointer option to my laser pointer. Right, so this was the original budget line. There was no non-labor income. Now you get this $1,000 non-labor income, right? But the provision is that for every dollar you then earn by selling your labor, the government takes away 50 cents. So that's like half of any wage is taken away. And so this new wage rate is going to be 0.5 times the original wage, right? So that's a lower slope naturally. So this then is the new budget line, correct? So let's see what this does to the hours worked of an individual who is already working to begin with, right? So the person who's working to begin with is optimizing at point P, working 110 minus 70 hours, this gap here, which is 40 hours, right? And then this program happens, and now the worker optimizes, as you can see here. Well, where does the worker optimize? It seems the worker optimizes at point R, right? This is the new budget line, and this indifference curve here is tangent to the new budget line at point R. Now you can break this up into an income effect and a substitution effect. So the income effect is simply going to take you from P to Q in a northeasterly direction, assuming labor is a normal good. Right? Labor and consumption are both normal goods. So you're going to move in that direction. So that immediately causes the worker to consume more leisure, meaning work less. Right? So the income effect of this change, of this welfare program, causes the individual to consume more leisure, that is, work less. But to this must be then combined the substitution effect, which works in the same direction as the income effect. The substitution effect, and you get that by doing what? You get that by going from point Q, right, which is where this imaginary budget line, parallel to the old budget line, is tangent to this indifference curve, right? But then you move to the final point here, which is where this indifference curve is tangent to the new actual budget line, not the imaginary one, but the actual one. So Q to R is the substitution effect. And this too, as you can see here, causes the consumer, the worker, to consume more leisure. Right? So why is this happening? You know, why are the income effect and substitution effect in the same direction? Well, that's because of this provision that every dollar of earned income is going to cause the cash grant to reduce by 50 cents. What that does, as I mentioned, is that causes the effective wage to reduce by 50%. Right? So with a lower wage, leisure is cheaper. Remember, the price of leisure is the hourly wage. Right? So with cheaper leisure, the worker substitutes out of consumption into leisure. Right? So that sort of bolsters the income effect. Right? So in the end, the worker definitely consumes more leisure, works less. So this program is definitely going to cause hours worked to reduce. Right? So if you have a program that combines a grant, with this type of tax on wage. What do I mean by tax on wage? The fact that for every $10 you earn, the government can reduce your $1,000 grant by $5. What this does is it effectively reduces your hourly wage by 50 cents, by 50%. Right? Instead of taking home $10 per hour, you're actually in effect taking home just $5 an hour, because the government reduces your grant by $5 for every $10 you earn. Right? So you have this flattening of the budget line, and that causes a substitution effect into leisure, out of consumption into leisure. Right? So this is going to cause a worker to reduce hours worked. Yes? And here we have a slightly more complicated real-life example. This is the earned income tax credit. So like a lot of government programs, this is a tad complicated, but let me work you through this. Right? So it says here how the EITC, the earned income tax credit, works. Right? Now again, these numbers may have changed. You know, the government just keeps tweaking its rules and regulations from year to year. So this information could be somewhat dated. But what we have today works in a pretty similar way. So it says here, a household could claim a tax credit of up to 40% of earnings as long as earned income is less than 14,040. So let's say you have zero non-labor income and you're not working, right? And you decide to earn $1. Right? If you decide to earn $1, what the government is going to give you is a tax credit of up to 40%. In other words, the government is going to give you 40 cents. So your effective wage will now become $1.40. You follow me? So if your original wage was $1 and you decide to work an hour and earn that dollar, the government gives you an extra 40% of what you earned. So in effect, you're making $1.40 per hour. And you continue to enjoy this until your earned income equals 14,040. Right? So it says here, as long as your earned income is less than 14,040, the household's effective hourly earnings should be 1.4 times its actual hourly earnings. Right? So its actual hourly earnings is $1. Effective hourly earnings should be 40% higher, meaning 1.4. Correct? So let's now look at the limit. Remember, this can be availed of as long as earned income is less than or equal to 14,040. So let's say you have a household that hits this max, this 14,040. What is the household's actual income going to be? It's going to be 14,040 raised by 40%. And how do you raise a number by 40%? You multiply it by 1.4, as you may know. Right? How do you raise a number by 20%? Multiply by 1.2. Right? Simple math. How do you reduce something by 20%? Multiplied by 0.8, which is 1 minus 0.2. Right? This is math that you may know, but I'm just reminding you. So the household's actual income now, which is earned income plus the tax credit, becomes 19,656. So what is the actual tax credit being received? It's the 19,656 minus the 14,040, which is a sum of $5,616. So this is the amount of tax credit that the household receives once it is earning 14,040. Right? Now, what the government says is, the household is eligible to continue receiving this sum of 5,616, this tax credit. Right? The household continues to receive this as long as earned income is less than 18,340. In other words, between earned income of 14,040 and 18,340, for every dollar earned, the household takes home that entire dollar. It's no longer getting that extra 40%, right? Correct? That extra 40% is calculated off the 14,040. So anything earned more than this, you don't get that extra 40%, but you get to keep your entire hourly wage, right? So in this section between earned income of 14,040 and 18,340, the household's hourly earnings are exactly what the market pays it. So if the household is earning $10 an hour, it's going to take home the entire $10. Right? In this range, earning less than 14,040, for $10, the household is actually taking home $14, 40% higher. Right? Now in this range, 14,040 to 18,340, the household takes home exactly the $10. Right? But it continues to receive this 5,616 tax credit. That it continues to receive as a lump sum. Think of it as a lump sum. Right? Now once earned income reaches 18,340, right? How much is its actual earnings? You know, 18, this is the labor income. To this you add the 5,606 earned income tax credit, and that gives the household an income of 23,956. Right? Now for every dollar earned above 18,340, right? For every dollar earned above this, the tax credit of 5,616 is reduced by 21.06 cents. Right? In other words, there is now a 21.06% tax, let us say, on hourly earnings in excess of 18,340. Right? So the household's effective hourly earnings, becomes 1 minus 0.2106. That's basically 21.06 cents written in dollars, right? That times its hourly earnings, right? Now, at this rate of reduction in the tax credit, it would fall to zero once earned income reaches 18,340 plus, and you take the tax credit of 5,616 that the household was receiving when it was earning 18,340, right? And you divide that by this rate of reduction, right? And that gives us $25,666.67. In other words, as long as it earns up to that much in excess of 18,340, it would continue to receive some earned income tax credit, right? But once it earns an additional 25,666.67, additional meaning above the 18,340, the earned income tax credit becomes zero. Because remember, if the household earns more than 18,340, the government takes away 21.06 cents for every dollar earned. Right? So what this of course means is that in this range, the household's effective wage is going to be less than its actual wage, the wage it is actually paid by the market. The effective wage is reduced by 21.06%. Right? So this gives us a kind of complicated budget line. Looks like this. So this will become clear in a second. Let me go back to my pen pointer. So this is what we have. If the hourly wage that the labor market pays is W, if that's W, then this slope here is going to be 1.4 times W, because the government is paying a 40% earned income tax credit. Correct? Now this credit can be availed as long as earned income is less than or equal to 14,040. So that's this point here. Remember, that original budget line is what shows us the actual earned income, the amount that the household earns from selling its labor. That's given by this, right? The other line gives us the household's actual income. That is earned income plus the tax credit, right? So in this range here, the household makes 1.4 times its wage up to point J, correct? Now what happens between earned income of 14,040 and 18,340? In that range, the household essentially keeps the 5,616 earned income tax credit, but gets nothing in addition. Right? So in that range, the wage here, see this wage here, that slope, well, that's equal to W also. So this section of the budget line is parallel to the original budget line that describes the household's earned income. Right? And this state of affairs continues until when? Until earned income is 18,340. Right? So you see this gap 18,340. This gap here is again the 5,616. Correct? Now any income earned in excess of 18,340, right? 18,340 plus 5,616 gives us this 23,956. So this in fact is the household's total income when its earned income is 18,340, right? But as by the provisions of the law, if even $1 is earned above 18,340 by selling labor, if labor income exceeds 18,340, then the government starts to reduce its earned income tax credit by 21.06 cents, was it? 21.06 cents? Yes, for every dollar earned. So in this range here, you see this wage is going to be W times 1 minus 0.21 what was it again? 21.6 cents, right? 21.06 cents, rather. So 0.2106. So you see in this range, the slope is less than the slope of this line here, which is double. Right? And so this continues until income hits 45, that's rounded off here to 007. So really it's 45,006.67 right here. This is the actual amount. It's been rounded off to 007. All right, and that's when the household receives no more government assistance, and any earnings above that, will take it back to its original budget line. Correct? So this is a pretty complicated budget line that results from the earned income tax credit program. Right? It has multiple kinks. How many kinks does it have? Now that's kink number 1, and that's kink number 2, and that is kink number 3. Correct? So what is the effect of this program on incentives to work, etc.? Okay, let's take a look at that. The EITC and labor force participation. Right? So let's say that you have an individual who is currently not working, right? So this is before the EITC program was introduced, right? And point E is the point of no work, and you can see here that the worker's best point is in fact E. This indifference curve here is exactly, tangent. It's very poorly drawn, I think, but it's supposed to be tangent at point E. Correct? So it's optimal not to work, correct? But then you have this program coming in. What this program does is it raises the wage, the effective wage, by 40%, at least in the beginning. Correct? It raises the wage by 40% in the beginning, right? And so with this steeper curve, you can see here that now the worker's reservation wage may be exceeded, right? The worker's reservation wage may be exceeded. And so and the worker may find it optimal. Point A now may be optimal. So what the worker does is now the worker starts to work a little, consume less leisure, than 110. So work hours are now that. That's hours of work. So the earned income tax credit actually serves as an incentive to work, right? Because the government is effectively raising the worker's wage to 1.4 times its, the worker's original wage, right? So this hike in the worker's effective wage causes the worker to substitute out of consumption, out of leisure into consumption. Leisure has become more expensive. Remember, the price of leisure is the wage, right? And the effective wage has gone up 40%. Correct? So this may happen. So it says here at the bottom, the household maximizing utility at point E no work may, after introduction of the EITC, optimize at point A, meaning begin to work. So the EITC may boost labor force participation. What about the hours worked of those already working? So let's say you have an individual who was working to begin with before the EITC program was introduced. The worker was already working, so the worker was at point B. This is where the worker was, and the worker was already working that many hours, right? And now the EITC program kicks in, and the effective wage goes up 40%, because the government's giving a tax credit of 40%, right? And so what this does is it may cause an income effect, correct? So you have a substitution effect and an income effect, but if the income effect dominates, you may end up with the worker moving to point A, right? And at point A, you can see that the worker chooses to consume more leisure, work less. So you have this odd sort of result is that the EITC program may cause those not working to begin to work, but it may reduce the hours worked of those already working. Right? So that's a possibility with the EITC program. That's what microtheory tells us, right? Next, let's look at labor supply. So changing topics now. Let's look at labor supply over a worker's life cycle, right? And what's been observed generally is that wages are low when workers are young. Wages rise with time, and this happens essentially because the worker is accumulating valuable work experience, right? So the worker's human capital tends to rise as the worker ages, right? And wages peak at around age 50, and then after that remain stable or slightly decline. And the decline can take place because the worker is, as the worker ages, losing some human capital, you see. Perhaps new things have been invented, new computers have been invented, and the worker doesn't quite know how to operate new machines, right? And so the worker's wage tends to flatten out, stagnate, or perhaps even fall, right? So this has been observed about wages, right? It's been observed that hours worked have a similar profile, right? So that's what this is trying to explain. So let me show you the diagram that we have here. Right, so the diagram on the left shows us how wages change over the life cycle of a worker. So on the horizontal axis, we're measuring age. At age 50, wages are at a peak, and thereafter they start to fall. And it's been observed that workers' work hours, the labor supply workers, follows a very similar trajectory. Young workers work fewer hours. Hours worked tend to rise, and then reach a peak at around 50 and then start to fall thereafter. So you have a very similar shape, and the question now is there a connection between these two things? Right? That's what this theoretical question is, and the answer is yes. In fact, the shape on the right is a result of the shape on the left, right? And how is this explained? Right? This is called the intertemporal substitution hypothesis. People substitute their time over the life cycle to take advantages of changes in the price of leisure. What's the price of leisure? The wage. So early in life, when you're young, your wage is low, and so leisure is cheap. So you consume more leisure, you work less. Correct? When later on, when wages are high in middle age, people work long hours because leisure is expensive. right? And when wages drop once again in old age, people again enjoy more leisure, work less, because once again the price of leisure has dropped. Correct? Now, in this intertemporal substitution hypothesis, there is no income effect in this story. Why is that? Because lifetime income is constant. Only its rate of disbursement changes over time. So you're talking about a worker whose lifetime income is actually constant. It's just that it's paid differently over the life cycle. You get less of it. Think of this pot of money. That's your destiny, right? There's a fixed amount of money that you're going to earn over your life, right? And it trickles down to you from year to year to year. Now, early in life, you get a very low, small trickle. You get very less of it every year when you're young. As you age, the trickle becomes a steady stream. Right? You get a stream of money. And as you hold it again, it becomes a trickle. But the pot itself, you're going to get all that money. But the timing of disbursement is what changes. You get less when you're young, you get more per year, per hour as you become older, and it again reduces the rate of disbursement of this money, this pot of money, reduces as you become old. Right? So there is no income effect in the story because lifetime income is constant, right? This is the intertemporal substitution hypothesis, which explains why the trajectory of hours of work is very similar to the observed trajectory of wages. And here we have some actual real-life data for the US, and we can see here that the labor force participation rate over the life cycle, in fact, has that shape that you were just seeing. So early in life, when people are young, the labor force participation rate is low. People are consuming all their time as leisure, because leisure is cheap. Right? Wage rates are low when you're young. You're capable of earning a low hourly wage, so leisure is cheap. You may choose to not work at all. Right? So hence labor force participation rates are low for young people. And then as your earning potential increases, you start to work. Labor force participation rises. It's a peak. Well, the peak here is actually around not at 50. It seems much earlier than that. I'd say around 40 in this diagram. Right? And thereafter the decline starts. Correct? Hours of work over the life cycle. Right? And again, theory told us that it's supposed to look like, what is it supposed to look like? Hours of work is supposed to look like this, correct? Because of the intertemporal substitution hypothesis. Does the data bear this out? Well, somewhat. You see certainly a rise from as young workers become older, right? Correct? But you don't perhaps see a decline later in life. You see a sort of flattening out, maybe a very slight decline here, a slight decline, but it's not as dramatic as, not quite like that. It's more of a sort of a plateauing out and a very gentle decline towards the end. Right? So what theories that's borne out then? This intertemporal substitution hypothesis is maybe a sound idea. Right? What about labor supply over the business cycle? What's the business cycle again? It's the way GDP behaves, right? You have economic booms, that's when GDP rises, and then you have recessions and GDP falls, right? So booms, recessions, right? That's how the economy behaves. And each of these recessions followed by booms back to recession. That is a business cycle. So essentially what this is asking is what happens to labor supply in a recession, right? And here you have two effects. You have what's called the added worker effect. So when there is a recession and the main breadwinner's earnings reduce, or the main breadwinner loses his job, this causes secondary workers in the household to enter the labor force to augment or to supplement the family income. Right? So let's say you have a father who loses his job. His teenage sons may decide to work to supplement the dwindling family income. Right? So this suggests that in a recession, the labor force participation increases because these two teenage sons who weren't previously in the labor force now enter the labor force. Right? So then you have an opposite discouraged worker effect. And what this is saying is that in a recession, the scarcity of jobs may cause some workers who are looking for work, unemployed workers, to become discouraged in their job search and to simply stop looking for work. Now remember, if a worker stops looking for work, if an unemployed worker stops looking for work, he is no longer unemployed. He is in fact out of the labor force. Right? And this causes labor force participation to fall. Right? So the added worker effect causes the following. The added worker effect causes a recession to raise the labor force participation rate. Right? And by the discouraged worker effect, the recession causes the labor force participation effect to in fact reduce. So you have these two opposite effects. Well, there is evidence that the discouraged worker effect dominates. So on the whole, the labor force participation reduces during recessions, rises during economic expansion. In other words, labor force participation is pro-cyclical. Right? What does that mean, pro-cyclical? It means that it mimics the business cycle. Right? If GDP is on the rise, labor force participation rises also. It's pro-cyclical. Right? Let's look briefly at the decline in the labor force participation of older men. Remember, I showed you early on in this in the lecture on part one, part one of this two-part lecture, that between 1900 and 2010, the labor force participation of those older than 65, males older than 65, has sharply decreased. Right? And one theory is that disability benefits have played a role of disability benefits. So disability benefits are a kind of non-labor income. Right? So if you're a factory worker, right, and you've been working hard all your life, by age 65 you can perhaps claim some disability. Right? Maybe you've suffered injuries at work or your health has declined, etc. Right? Let's work with an extreme example. Let's say you're a coal miner, right? And you've been breathing in coal dust for many, many years, and you've got black lung disease, which is a kind of lung cancer, and so you've got on disability. Right? Now, this disability never used to be around in the old days. Right? Back in 1900, the coal miner just pretty much worked himself to death. There was no retiring, really. Right? But with the coming of the welfare state, government has become generous with its disability payments. And so disability payments are a kind of non-labor income. And we know what non-labor income does. It raises the reservation wage. Right? The worker now decides to stop working once the worker becomes eligible for a disability payment. Right? So how big a role have disability payments played in the declining labor force participation of older men? Right? And there was a study done on Canada. So here's a natural experiment that we have. Before 1987, disability benefits were more generous in the Canadian province of Quebec, the French-speaking province of Canada. Right? More generous there than in the rest of Canada. In 1987, the rest of Canada made its disability benefits just as generous as Quebec. So here we have a natural experiment. Right? So you have a control group and you have the other group. Right? Control group is Quebec, I guess. Nothing changes there between pre-1987 and post-1987. Right? And the rest of Canada is the group upon which an experiment is being conducted. They're the ones receiving the vaccine, so to speak. Right? So a difference in differences approach was used to estimate the effect on the labor force participation rates of 45 to 59-year-old men of this increased generosity of disability payments in the rest of Canada. It says here, let delta, Greek letter delta, delta LFPR, labor force participation rate, denotes the change in the labor force participation rate from pre to post 87, right? So that's what delta LFPR is. So what's the delta LFPR for the rest of Canada? It can be broken up into two parts. It's the change in the rest of Canada due to changes in disability benefits, plus change in the rest of Canada due to other national factors. Right? Similarly, for Quebec, the change in the labor force participation rate pre and post 87 can be broken up into two parts. Change due to a change in disability benefits there, plus change due to other national factors. However, in this equation here, change due to change in disability benefits in Quebec, well, that's zero, because there was no change in disability benefits in Quebec. Right? It was generous before, and it remained equally generous afterwards. So that part's zero. Right? So what we can do now is we can look at this. The change in the labor force participation rate in the rest of Canada minus the change in Quebec. Right? So that would be this equation here, this item in brackets here, minus this item in brackets here. Correct? Now when you do that subtraction, you see this change due to changes in other national factors. Well, it's one country. Quebec is in Canada. So one would expect this here, this bit here, to be equal to this bit here. Changes due to national factors. Right? That would tend to be common because Quebec is part of Canada. Right? So when you do the subtraction, you're essentially left with just this part. That's all you're left with. Change in the labor force participation rate in the rest of Canada due to changes in disability benefits there. Right? So this approach, this difference in differences approach, can give us a handle on, figuring out the change in the labor force participation rate among older males in Canada due to an increase in the generosity of disability benefits. So what's the finding of this study? The finding is that the labor force participation rate of older males in the rest of Canada fell by 2.7 percentage points due to the increased generosity of disability benefits there after 1987. Right? So this, in a sense, proves that making disability benefits more generous reduces labor force participation of older males. Because disability payments are a kind of non-labor income. And we know that a hike in non-labor income does what? Raises workers' reservation wages. The workers become more choosy, so if the wage they're currently receiving, well, the wage they are currently receiving may now be less than their new higher reservation wage. Right? And so they may decide to stop working. Right? And that brings me to the end of my lecture, part 2 of Chapter 2, Labor Supply.